What's up, y'all? We are starting our Unit 6 polynomials, and today we're going to be talking about adding, subtracting, multiplying polynomials. We're going to first start with talking about the degree of the function, which is the highest power of the function. So we'll go ahead and look at an example here. When you're trying to determine the degree of a function, you want to look at that polynomial's highest exponent. So in this first example, this is degree 2 because the highest exponent is a 2. In this second example we look at, the biggest exponent that we see is the fourth power. Even though we have an x squared in there, even though we have an x all by itself, this is degree 4 because the biggest exponent is 4. Both of those examples are also written in standard form. So standard form means that those terms are written in descending order from the highest exponent to the lowest exponent. So x squared comes first, then x, then no x. And in that second example, x to the fourth would come first, then x squared, then x, then no x. So in order to be considered a polynomial, the exponents cannot be negative or have fractions. So let's look at all these special names that we have for degree 0 through degree 4. So degree 0 could be called a constant, like the number 5, or -2, or 1/4. Notice how I'm saying the exponents cannot be fractions or negative, but constants are allowed to be fractions or negative. A term that has degree 1 is called a linear term. So that's like x or 3x or -1/2 x. Notice how those negatives can be part of the coefficient, but not part of the exponent. Quadratic, we just recently looked at when we were graphing quadratics. That's going to have an x squared. At the end here, we see this x squared minus 9, which is a difference of squares. So we have a quadratic polynomial here. Cubic means that the term has 3 as the highest exponent. So x cubed, or like this polynomial, x cubed minus 2x squared plus 7, all have degree 3. Quartic, just like a quarter, is x to the fourth, any x to the fourth term. And then anything higher than degree 5 we'll just call degree 5, degree 6. So for example, if I have a term that has x to the 5th, I would just call that my degree 5 term. Or if I had a term that was x to the 6th, I would just call that my degree 6 term. Understand that we can identify an entire polynomial as a certain degree polynomial, but we can also refer to each term with these special names. So for example, when we take a look at this number 1 in that first set of parentheses, I could identify those 3 terms as a quadratic trinomial because the highest degree is 2 and there are 3 terms. But I could also identify each one of those terms individually with their special names. X squared is my quadratic term, 7x is my linear term, and -3 is my constant term. We should know how to do these 3 U-tries. In the first one, notice that there's a plus sign in the middle, so you are combining like terms. You can only combine like terms with the same degree term. In number 2, you've got a minus sign in the middle, so make sure you distribute that minus sign. And then at the bottom, that is a multiplication problem, so make sure you use the distributive property to multiply those 2 terms together, and then combine like terms at the end. So go ahead and pause the video here, try these 3, and come back when you're done. All right, so for this first one, notice how I wrote the term with the highest degree first, so that x to the 5th first. Then I'm combining those x squared terms, or those quadratic terms, then the linear terms, and then the constant goes at the end. I didn't ask you to do this part, but this is a degree 5 polynomial because the highest degree is 5. In this second example, we distributed that negative sign, and now we can combine like terms. I'm writing the term with the highest degree first, so that -2x to the 6th. Then the next degree term, x to the 5th. Then I can combine those quadratic terms, which is going to give me -7x squared. And then I can combine those constant terms, 9 plus 1, which is 10. This is a degree 6 polynomial because the highest degree is 6, or the highest exponent is 6. In this next example, we're using the distributive property. So we need to multiply x squared times everything inside that set of parentheses. Notice what happens to the exponent here. X squared times x is x to the third power. It pops that exponent up 1. Same thing with x squared times 2 would just be 2x squared. Then I need to multiply 2x times everything. So I'm going to do that in a different color so you can see. 2x times 3x is going to be 6x squared. 2x times 2 is going to give me 4x. And then I'll use another color to multiply that negative 5 times everything. Negative 5 times 3x is going to give me negative 15x. Negative 5 times positive 2 is going to give me negative 10. So you could have drawn those arrows here to show that you're multiplying x squared times everything, 2x times everything, and negative 5 times everything, but I find that those arrows get very confusing. You could either use different colors like I did, or you could cover up each term as you're multiplying these out. So I'm just going to go ahead and combine like terms here. I'm putting that 3x to the third first because my cubic term is the largest degree that I see. Then I see 2 quadratic terms, so I'm going to combine those together to give me 8x squared. Then I see 2 linear terms, that 4x minus 15x, and together that makes negative 11x. And then last but not least, I have my constant term, which I'll put at the end. And overall, this entire polynomial is a cubic polynomial because the highest degree is 3. So I could either call this degree 3 or I could call this a cubic polynomial. So that's it for your introduction to polynomials. We'll see you next time. Thanks for coming.